Yeah, okay, works. Just a second, I'll just check my audio out. Yeah. Yeah, okay, works. Just a second, I'll just check my audio out. Yeah. Right, everything's set up. Yeah. Uh-huh. Put the chat out. Yeah, it's fine over here. So, right, I'll be learning about tries today, right? I haven't solved a single question about it. Prefix tree is a tree data structure used to efficiently store and retrieve keys in a data set of strings. Various applications of this data structure, such as autocomplete and spell checker, implement the try class, initializes object, insert the string word into the try, boolean search string word returns true if the string is in the try, and false otherwise. Boolean starts with returns true if there was a previously inserted string word that has the prefix, and false otherwise. Yeah, sure. Let's take a look at the theory part of this. भाई तू क्या बताओ भाई. Extremely well. So today we will be starting with the try. So just a second. I'm not sure if you can. Just a second. I'll check if you can see the screen share. Something's up with the screen share, है ना? I just something's up with the screen share. Reset it. Yeah, I need to reset this. So properties, video is fine. If I switch to this guy, then this works. If I switch to this guy, then this works. If I switch to this guy, then this works. So all of this is working, I'm guessing. But so all of this is working, I'm guessing. When I move it to so all of this is working. This guy, right? If I switch to an application share, this guy, right? If I switch to an application share, but this guy, right? If I switch to an application share and I move it to this guy, right? If I switch to this guy, right? If I switch to an application share, oh holy shit, that just happened. Well, this is not okay. Oh holy shit, that just happened. Well, this is not okay. Oh holy shit, that just happened. Well, this is not okay. Oh holy shit, that just happened. Oh holy shit, that just happened. Well, this is not okay. Oh holy shit, that just happened. Just give me a second. Add a window capture. Window capture. Just give me a second. Window capture. Just give me a second. Window this case, randomize this. Right. Second. Window this case, randomize this. Right. Second. Just give me a second. Yeah, now case. All right. Right. Second. Yeah, now case. All right. Right. Second.
Whatever you can call it, it has.
Yeah, now case. All right. Right. Second.
Whatever you can call it, it has.
Yeah, now case. All right.
Whatever you can call it, it has.
Yeah, now case. All right.
Whatever you can call it, it has.
Yeah, now case. All right.
Whatever you can call it, it has.
Yeah, now case. All right.
Whatever you can call it, it has.
Yeah, now case. All right.
Whatever you can call it, it has.
Yeah, now case. All right.
Whatever you can call it, it has.
Yeah, now case. All right.
Whatever you can call it.
Okay. Okay. Okay.
Array of size 26 and it has a boolean flag. Okay.
Okay.
Now there will always be a root. Array of size 26 and it has a boolean flag type. Okay. Now there will always be a root. Array of size 26 and it has a boolean flag type. Okay. Now there will always be a root. Array of size 26 and the data structure. Now initially the root will be having like this is a trie. Whenever I say trie, I mean that it has an array of size 26 and it has a boolean flag. Okay. So this is a trie. That means it has an array of size 26 and it has a flag. So I can say let's mark flag over here. For this flag is false, so let's mark flag as false. Now it has an array of 26, but as of now I'm not marking it. So assume this as the 26 size. Assume this is 26 size. I'm not marking it. We'll just mark whatever is required. Now let's come across and try to insert the first word, which is apple. Now whenever we are saying insert apple, what you do is you start with the root. Yes, you start with the root and you ask the root. Now remember, whenever I say 26, 0 means A, 1 means B, 2 means C, and Z means 25. This is how I will be calling up the indexing. Remember this. This is how I'll be calling up the indexing. So whenever I say hey for apple, what? You're starting at the root. You're starting at the root. What is the first alphabet? A. The first alphabet is A. Now you're going to ask, hey, listen, does A exist in your root? They'll be like, no. All 26 are as of now empty. Because whenever you just declare, that means it is empty. All 26 are empty. So you'll be like, okay, hey, listen, can you please go to the index 0 and insert A? I'll be like, okay. Now whenever you insert A, just make sure for A, you create another trie node. So A will be pointing to that trie node. Just make sure you create that. Now another trie, what does that signify? Whenever I say another trie, that means with the flag as false and again 26. Okay, now you're done with A. You're done with A. Now A is pointing to this. Okay, so for A, this is what you mean. So A is pointing to this trie. Now whenever you come to P, in order to come to P, what you'll do is you'll come to A's reference trie. So you have come up to A's reference trie. Now what's the next one? P. Now you'll ask this guy, does P exist? I don't see because it's a null. So what you'll do is you will simply take a P, yes, and again you'll create a P's reference trie. So please create a P's reference trie. Again you can create the P's reference trie and then P will be done. What's the next alphabet? Again P. So you're currently standing at P. So which is P's reference trie. This one you'll come to here and now you'll ask, does there exist a P? Because the next alphabet is P. No. So again you'll insert a P and you'll create a P's reference trie. So let's create a P's reference trie.
If you don't learn clean architecture and
Created. What's the next alphabet? That's L. Now where are you? You're over here. Who's the reference trie? Here. Does there exist a L? No. So what you'll do is, you'll simply take L and you'll insert it onto the reference try of P. Insert it and make sure you create another reference try for this, and that reference try will be having again flag as false, and this will be the reference try. So L is also done. Which one is the next? E. So when you come to E, where are you? You are at L's reference try. That means you're over here. Does it have a E? The answer to that is no. So what you'll do is, you will create a E and you'll create E's reference try. Yes, you'll again create E's reference try, but this time initially the flag will be false, because for E, when you create the reference try, this is how the try will be created. So A of 26, which is this, and then boolean flag equal to false. This is how it is created. But remember, whenever you come to E is completed, which means the word has been completely traversed. So it's completely completed. Now, since it is completely completed, what is the last reference that you're standing at? This try is the last reference where you're standing at. So since the word is already completed, you'll be like, hey flag, can you mark yourself as true? You'll be like, okay, let me mark myself as true. So let's mark himself as true and keep it. So this true signifies that E, this try, there is a word that ends with this particular E. Got this? Perfect. Now what we will do is, we'll come to the next one, that is apps. When I come to the next word, that is apps, for this A, we will be standing at true and we'll ask, does there exist an A? He says, yes, there exists an A. So our pointer will move to the reference try of A. So we are now over here. Okay. Next, does there exist a P? Yes, there exists. So you'll now move to the reference try of P. We will be standing here. Does there exist another P? Yes, there exists. So you'll move to the reference try of P. So you'll be standing here when we are at S. Okay. Whenever we are at S, we will be standing here. Does there exist an S? No, because there is an L, but there is no S. There is no S. So what you will do is, you will say, okay, since there is no S, let's create an S and its reference try. I'll create a reference try for this and I'll keep the flag as false initially, because I'm creating a reference try. So initially it will always be false. Going forward, I can say, what's the next? The next is nothing but, very simple. If I'm done with this, that means the word is complete. The word has been complete. And the word is complete, you know, wherever the last reference try is pointing, which is this, you'll just go over there and you'll say, hey, listen, can I do the flag to be true? Because the last reference try is ending over here. That means this is a particular word. So that is how you insert. Okay, next, APXL. So let's again do the same thing. You'll initially stand at the root. Do you have a? You have a E. Move to the reference. Do you have a P? You have a P. Move to the reference. Do you have an X? No. In this reference, you don't have an X. Put an X. The moment you put an X, create a reference try. Create a reference try. And make sure this is initially marked as flag equal to false. So APX is done. Do you have an L in this reference try? No. Put an L and again create a reference try of this and mark flag as false. Next, does there exist any word? No. So if there does not exist any word and you've already inserted this APXL, thereby you'll go back and say, okay, the last reference was standing here. So I'll just make it as true and I'll finish off my job. So if you carefully observe, for APXL, APX
So just a second, I'll be right back, yeah. Right, so OBS is glitching a lot for some reason, and I don't know why, but it is. I'll just put this on top and hoping it still works. It does, it does.
Cross. Let's start coding. Code that I
It works now. I know. And it's a bit weird. I don't know why it's happening, but all right, let's watch this.
will be writing will be industry standard. So I'll be maintaining class, functions, and everything clear to you as I move across. So let's start coding. Code that I will be writing will be industry standard. So I'll be maintaining class, functions, and everything. Don't, there's nothing to worry. You can just follow me and you'll learn the entire stuff. So what we are given is basically a class. By the way, the C++ code is on the left, and the Java code I have pre-written because I cannot write both the codes together. So for Java people, they can just follow me when I write the C++ code, and they can just look at the transformation into on the right hand side, but you can follow it because the syntax is almost identical, because I'm just going to use for loop and arrays, so that doesn't matter, right? So initially given the class try,
70 मिनट 70 मिनट है तुम्हारे पास
70 मिनट का तो पता नहीं, लेकिन
and then there's a method constructor, and then they're given insert. So there's a functionality of insert, as we discussed. Then there is something as search, when they say that, okay, take this word and tell us if it exists or not. And then there is something like boolean starts with. Does there exist a word that starts with this particular prefix? Okay, so what I will do is, as I said you, that there will always be a struct node. So let's write the struct node, right? And what did I say you? There will always be a reference node. Now, my pardon, when I was discussing, I wrote int, but there will always be a node star, and you can probably keep it as links, because for every
Exactly, that's what I was wondering half the time, because if it's an array of integers, then how are you supposed to reach the next node? It's probably like node star and then an array, right? Yeah, that's what I was thinking too.
character, there will be a reference link. So assuming all are lowercase, I'll keep it as link 26. Now then I'll keep boolean flag equal to false. Initially, that's what I'll keep. That is what I have initially kept. Now we have a try, right? What are the stuffs that we require? We require one stuff which tells me does there exist that stuff or not. We'll come to that afterwards. Now assume that this is the initial stuff of struct we have. Now we are having a try. So in try, what's the first thing that we require? We definitely require the root. So I can just define the root, because initially every try will have a root. So I've declared that. And after this, what I'll do is I'll say root equal to, yes, root equal to new of node. So whenever this constructor, like whenever the class's object is created, we will create a root of new node, which basically signifies that, hey, listen, we have, this is absolutely a new object for this particular class itself. Okay, this is what we will always have. Anytime anyone creates a constructor, he'll get a new try for himself. Okay, after this, we have an insert of word. So if you remember, while inserting, we always started with the root. So let's create a node star node equal to root. So this is basically a dummy variable node, which is initially pointing to the root. That is what we have started with. Now we need to insert every character. So let's just move across word.size or length, whatever you want to take. Now, what do we want to see? Word I, because we need to check if the character, what's the character? The character is word I. Does that exist in your try or not? So for that, what I'll do is, I'll just create a function will contains key.
And it glitched again, I'm thinking. Yeah, see? Not working. That is so weird as shit, bro. Hana. How do I reset it? Restart capture. There's a button for this.
Because this is what it means, links. If the links of ch minus a, because I said a is 0, b is 1, c is 2. So if this is not equal to null, then you'll be like, hey, listen, that means it does exist. That means this character does exist. So while inserting, it's very important. If currently I'm standing at this node, which is the root, if node contains key, because this node, this is the reference try that I'm standing at, I'm calling the contains key for this, and I'm passing the character as word I. Does it contain the word I? If it does not, then what I will do is, okay, you don't contain, so you have to keep it with you. You have to keep it. So what I will do is, I'll again create a function which is nothing but void put, where I say, hey, listen, this is the character ch, is this the character ch, and this is the new node that you have to put it across.
Why is he doing all this for each node? Shouldn't the function handle that?
So what I'm saying is, okay, that is perfect.
Like the function inside the class.
So on links, yes, on links, that is ch minus a, can you say for this guy, the reference node is this? So basically I'm saying this is the new character, and for this is the reference node that I'm saying. So assume when you started with apple, you'll pass a, and you'll pass a new try for that. So apple's a will be pointing to new try. That is what this put will do. Okay. So what I'll do is, I'll say, if it does not, yes, if it does not, then I'll call node and I'll say put, can you put this apple, like word I, with a new reference node, new try. So just make sure you put this new try. So once you have put this, now apple has been put, like a has been put of apple. Now can you just go to that? So you'll say node, can you go to the next one? So in order to get the next one, what you can do is, probably we can write something as get function, because something like node or void get, something like node star get, and like character ch, and it'll be like return, where is this pointing to? Link ch minus a. Ch minus a is where it's pointing to. So what I've done is, I've put across, so I'm currently standing at the root. Remember, you're currently standing at the root, and the root you have put across. But now you have to move to the reference try. So you say, hey, can you just move to the reference of this word I? Just move to the new try. This moves to the reference try. Moves to the reference try. So this is going to happen every time. Yes, this is going to happen every time, because this is how you create the new reference node, and this is how you move. So you move to the new reference try. And once you move to the new reference try, you will insert. Again, you'll come across and you'll see in the new reference try is the word I exist. If it does not exist, again create new. Keep on going.
It should be node equal to something, right?
on going. And once this ends, once the entire word ends, can I say this node will be standing at the last reference try? And if it's standing at the last reference try, can you say set end something like this, where you say, can you please set the end? So probably I can also write boolean set end, where I say, okay, the flag will be turned to false, true. So basically, this was the last reference node, and it's a set end. So it'll go to the set end and say, okay, for this node, can you just turn the flag to be true? So at the last, you will turn the flag to be true, stating there is a word that exists. This is as simple as it gets. The complexity will be simply bgo of length of the word. Is the complexity for insert is bgo of the length of the word. Perfect. We have done the insert. Next, there is something as search. Now, when you're searching, you always start with the
Just a second, boys. Gonna wish someone a happy birthday. Alright, I set up a reminder now. I usually can't remember birthdays, so I just put it on a calendar and forget.
now. You're standing at node. You're standing at the starting point, that's tree. Now you will be looking for word I. Does it exist? Now how will you do that? If node contains, because you'll call contains again. Remember, why am I writing these functions? So that I can reuse them. I don't have to write again and again. This is what you call production level code. Remember, these kind of codes you should write in an interview, then they'll be like super happy. Does it contains word I? If it does not contains, in case it does not contains, then there is a problem. If it does not contains, that means the word does not exist. So can you please return it? And if it contains, why don't you get me that? Yes, why don't you get me that? Something like node get.
एक छोटी सी बच्ची को रेस्क्यू किया था। वो भाग न जाए इसके लिए उसके प्राइवेट पार्ट में ग्रीन चिली।
Just make sure you get me. If it does not contain what I, that means it does not exist, or else you just get me that and you move across. So once you're like going to the reference, going to the reference, going to the reference. At the end, how can you determine? Yes, at the end, how can you determine if this node is a word? Like you have found a word. It's very simple. The last flag has to be true. So probably you can write a function as boolean is end, and you can return the flag's value. So can I say at the end, if I say at this reference is end, if that's equal to true, I can say return, or you can simply return the node is end's value. Without complicating things, you can just return this node is end's value. Then you will easily get to know if there is a word that exists. Like you go across, and the last reference where you end, if that is end is true or not, you just simply say. What about starts with? Like how are you going to implement it? So I'll keep the Java code as usual on the right so that you can just follow me. Now how are you going to implement it? As usual, you're going to start off with very simple at the root. So let's start off with the root, and then you're going to
But I think I get it. I'll try and implement it on my own. You know, didn't really. I don't think I'm gonna copy all of that. It's just struct node, and it's gonna have node star. Prefix only of lowercase English letters, right? Yeah. Okay. And should I do a vector int? I can. Whatever, we'll see. But it also uses an unordered map, right? I think that's the more robust way to do it. All right, now characters 26, and then you have interesting. I know flag will be false, and I want all of these to be. Should I do a C double pointer magic? I can. But we'll see. Anyways, node. Node equal to new node, right? And if I want to insert, just a second. Yeah, okay. So insert is gonna be what? If I want to insert a word, right? I'm just gonna say auto ch in word, and if node, yeah, how do I set it to a null pointer? How do I set it to a null pointer? Let's see.
Let's start off with very simple at a root. So let's start off with the root. And then you're going to go across the length, which is definitely word dot length. Okay. And right after this, what you will do is you will be like, hey, listen, does this word exist? Simple as this. If it does not exist, then it is false. If it does not exist, it is false. There is nothing to do. And if it does exist, just move to the next. You move to the next. And then, do you need to check for it true? No. If you have reached to a reference try, that means this can be a prefix. So there's no need to check for it. You can directly return it true. So the only difference between this and this is return true and return this. So if you write this code, for the search, the complexity will again be go will look across. So will I be running this code? Absolutely no. Why? Because I was explaining you. So it might be possible I would have done syntax errors. So for that reason, what I've done is I've pre-compiled the codes and I've submitted them at the particular platform, and I've given all the code links in the description, as well as where they write these lines inside like code. You see, I made sure that I always have.
Wait, do structs have constructors in them? Let's see, structs. class with the default access specifier is public, whereas class it's private. Okay. Right, so he didn't declare in here he did, otherwise he did not. And it's gonna be null by default, is it? Is that the way it works? Or it might, I have no idea. I can simply do this, right? Ch minus a. See, if it is a null pointer, then we know char ch minus a new node, right? Here I can simply say node equal to node char ch minus a. That's how it works. Ouch. Okay, is that how it works? Yeah. That should work. See, if I want to insert, let's say, apple, right? So it's gonna check node char ch minus a. 0 is a null pointer. In that case, insert it. Like create a new node, insert it. And then you move ahead, right? And node equal to node. Temp char ch minus a. Yeah. Finally. I can do that, right? I can. And then let's talk about search. So, same. Auto ch in word. No. Node temp equal to node if temp char ch minus a is equal to null. You simply return false. And otherwise you say compute temp char ch minus a. And you simply return true. No, you simply return temp flag. That is what you return. That search and then starts with is gonna be the exact same code over here. And we can note for auto ch and not in word and prefix. Right, if temp char ch minus a, that is if the character is found. Sorry, if the character is not found, then you simply return false. And if the character is found, you go to the next guy, and then yeah, by the end you can simply return true if you went through this entire loop. Yes, yes, that's it. Okay, I have no problem adding semicolons. Uh-huh. Right. It's gonna be node star. Same with this guy. Try and run this again. Line number 37 again. Same conversion. Any other problems? Node on conversion from node star to const node and for first argument. What does that mean? I think it's looking for a function inside my class to convert from node star to node. Member accesses misaligned address for type node requires 8 bytes alignment. Interesting. Pointer finds here. Memory cannot be printed. Let's ask ChatGPT about this. Oh god. What went wrong? Let's break it down. Oh, it's saying it works. No, there's an explanation. Struct node star cast. 26 pointers for lowercase English and has a boolean flag to mark the end of a well. Initialize the chars are to null pointer. Yeah, I did not. I have to do this for each guy. God damn it. How about now? Why didn't it work for him? My bad. It's gotta be Kaz. Yeah, but why did it work for him? Is this a standard implementation? Yes, this is a standard clean implementation. Then why did my guy do it like this? Where's the code? Because I'm just thinking that, okay, so they don't want us accessing. You don't want people accessing the members of your class directly, right? So you create a method for this. Yes, you can, and I guess this is also okay. Oh, fellow. Const correctness. No, lost methods for finding out whether uh, if a character reference exists. Having help method in node is good design practice. Encapsulation, high draw, array access, extend the try, variable alphabet, Unicode sim. Readability, maintainability, and large font. Okay. Okay, this is a more object-oriented design. Exactly, more right. What that guy did. Yeah. Got it. Got it. Got it. Got it. Right. That's true. Okay. Got it.
These functionalities. You will see people coding when they write these lines inside, like over here they will write it, but that's not a good practice. Then we try to create a readable code. You see, this code is so readable. No, okay. If it contains word, then it's false. Like if it does not contain false, you go to the next. It's so simple. Like it's so readable. If you just carefully say it's so readable. So make sure you write the code as I have written in the interview. Then only the interview will be super impressed, and trust me, they will not get a chance to reject you. So guys, I hope you have understood the explanation as well as the goals. Just in case you did,
Got
please
it.
this video. Yes, check out our SD sheet. You should definitely check it out, man, because a lot of people are trying it out and they're like cracking a lot of companies. So make sure you check out the SD sheet as well. I have kept it on our website so that you get all the code, video solutions, article links, everything. So yeah, make sure you check out all the links in the description. And yeah, if you're new to the channel, please do consider subscribing to us. And yeah, with this, I'll be wrapping up this video. Let's be in the next one. Bye bye. If you welcome back to the channel, I hope you guys are doing extremely well. So today we will be solving the second question on the try playlist, which is implement try part 2. Now, what does this question state? In the previous question, we did learn about how to insert, how to search, and how to check if there is someone who exists with same prefix or not. Now, if you haven't seen that video, please don't watch this video because this is an extension of the previous one, so you'll not understand anything. Please make sure you watch that video at first, then you can start with this one. So, what does the question say? The question is pretty much similar. It says that you'll be given a constructor which creates a try for itself, and then you'll be asked to insert a word. If you give a word, you have to store it. Then you'll be asked count words equal to.
Let's take a look at the question ourselves, huh? And I guess it's stuck again, which is sad. Why is this happening? Right, okay. Ninja has to implement data structure try from scratch, complete some functions try, initialize the try data structure, insert, we just did that, count words equal to. Ninja has to return how many times this word is present in this try. What does that exactly mean? Oh. Count words equal to. How many times this word is present in this try? Count words starting with how many words are there in this try that have the string prefix as a prefix. Sort of a DFS, no? Okay. Erase word. Ninja has to delete one occurrence of the string word from the try. Word is present in the try. You're going to use various dynamic and question. You need to leave memories to with them at the end of your solution. And jump in the try data structure. Coding Ninja was equal to coding. So word starting with then let's go from 1 2. Okay, yeah. Something Vivo. Oh. Oh, okay, so you can insert the same word twice and it's supposed to count all of them. So, right. Okay, so if I just store the count along with it, I guess I can, you know, that's a Samsung SAMSUNG. You've got the entire tree out there, and then you just do what you store a counter with each letter. So it's Samsung again, right? SAMSUNG. equal to and starting with, right? So in the case of starting with, you just return the number, and in the case of equal to, you return how do you return? Let's say Samsung and Samsung's Samsung, the next guy is true. That also has a count. Well, I guess it does. Alright, let's create that. And it's all just gonna be lowercase letters. Where are the constraints? T is 50, number of times functions are called, word, string, A to Z, small letters, and it's 10,000 operations. 1, 2, 3, 4, 5, 6, 7. It's 10 power 7. Yeah, just on the brink of it. Anyways, I am going to do something like this. Create a vector with, well, should I create a vector? I think I should create a map instead. And it's gonna map two things, right? It's gonna be, well, I can use a vector. So vector, and it's gonna store two things: pair of character is denoted by this. Pair fly equal to 0. Right. Okay, so you have node, and then node. It's actually gonna be node star, my bad. Yeah, so node equal to new node, right? And then insert. When I want to insert a word, what I'm going to do is I'm going to do something like this. Or auto ch in word. I'm simply gonna say if node start temp equal to node temp dot contains, is that what I'm going for? Do I even need to do that? I think I do. Temp contains ch. If it contains ch, and so we'll just bool contains ch. If it does contain ch, in that case, what I want to do is no, right, does not contain ch. I'm going to temp insert ch. Now I can just simply run this temp insert ch, and we will just implement this function. Insert. Now, if char ch minus a is equal to in that case new node if it is a null pointer, that means the character does not exist in that case. And well, ch minus a dot second plus equal to 1. Right, so let's say it was b had null comma 0. It's gonna be a new node and it's gonna be 1. That sounds about fair. Sounds pretty fair. And then I can simply say insert temp equal to get set. Char ch minus a dot first. And we will done. Okay, let's say we want to insert apple right now. Node is just null for now. In this case, why is this happening? Node is just gonna be null in this case right now. See, let's see what happens. If we node auto ch and word a temp insert ch. If it is null pointer null, you do this ch equal to new node a and then dot second plus equal to 1. Awesome. And then you go to p and then you say temp get ch. Works. Right? And then by the end I can simply say temp bag bag right. Count words equal to this. Now the same over here. So node star temp equal to no for auto ch in word. I can simply say temp equals temp get ch, right? And if temp is null, so we'll say ABC, right? A temp equal temp dot get A. Now B return temp flag dot second. Or I can just say temp dot okay, count word starting with. Hmm. Count word starting with, that's gonna be ABC, I'm guessing. I can simply say just do this. My node start temp equal node ch and whatever temp get ch. Now what you can do essentially is you can see if it is the last letter, then you can simply return the last letter over count. Otherwise what you can do is you can I guess that is a better approach, bro. है ना? And एक और constraint था. There's also erase, my friend. C is equal to word of I. And then temp equal temp get ch. Temp is equal to null pointer, then you return 0. Both starting with temp Finally, it is. Can we sort of like insert Excel this one? Just subtracting, right? I just need to access directly, bro. This is getting too many methods. CH in Word, temp equal to not insert, don't insert, right? I'm just gonna raw dog it, bro. Let's say we are at A. And this is equal to a 0. In that case, what you're going to want to do is, अगर ये 0 है यार, what do you do, man? Temp char ch minus a dot second, if that is equal to 0, you need to break. Where is 0? First equal to null. Maybe sure I want to go through all of it. Erasing is such a cunt, bro. कहीं भी 0 जाता था वो तो डिलीट करने ही आएगा सारे, है ना? Flag dot second. Ah, God damn it. Line number 3, right? Pair node star int. Expected this artist definition. Yes. Int for array substring. I'm errors of it. I gotta fix all of them. 26 0.0. Oh, see this I don't get. I'll put this on charging too. Damn, this is tough shit. Right. Okay. And I haven't exactly been. Yeah, what is this, yeah? You gotta keep on restarting this. Car sees when it's first. I'm lost. Let's try and take a look at
Now, in
what
the
this
previous
guy does.
question, we were like, you have to tell if there exists or not. In this question, you have to tell how many exist. Okay, you have to tell how many exist. Now, coming across, count. Towards
Right, so it actually fucking worked. ChatGPT was a little wrong, huh? Let me just take a look at. Yeah, I've been seeing this a lot. You know, it's getting wrong a lot. ChatGPT. No, am I deleting that? That is not okay. Oh, that is not okay. No. Each time insert ample increment. Can I use the nodes? Can I? I'll see what that guy does. What Striver does. Right. Interesting.
Starting with prefix. Now you, in the previous question said, if there exists someone who's starting with the same prefix. Now this time around you have to tell how many are there that start with the same prefix. So this is how the question is, and there's one more change. Where they say, hey listen, you have to erase the given word. So there are 4 functionalities that you have to implement. One is insert. The next one is count towards equal to. The next one is count towards starting with, and the next one is erase. So let's check this out. How will we do this? So let's check this example. They're saying insert Samsung twice. Insert Vivo, erase Vivo. Now count towards equal to Samsung. Samsung does exist twice, so 2. Count towards starting with VI. Now had you not erased Vivo, then there would have been 2 guys who are starting with VI. But since you have erased, it will be 0. So this is how you have to implement your try so that these functionalities are performed. So let's try out the first functionality, that is insert functionality. And I'm giving you these 4 words that you have to insert. Now, how is this question different from the first one? In the first one, you have to tell if there exist. Over here, you have to say how many exist. So you have to, like your brain works, right? You have to count. So what we will do is, we will declare a try over here, similar to the previous one, where we will be containing the links of 26 characters. But instead of having a flag which told us, hey, listen, true, means there does exist a word. Instead of that, we will have a variable end width equal to 0, and count prefix as 0. Now, these are integer variables which are going to count and end. And we will initially declare a root, okay? And the end width will be 0, and the count prefix will be 0 of this root. This is the initial try that is declared, which has count end width and count prefix. Okay, it also has 26 links. As of now, none of the links are valid, so you can say it's null. All the links are null. Now let's start with the first one and try to insert it. Apple, A for the first. A is the first one. Now let's see if A initially we start here. Does A exist? No. So insert A.
ब्रेकिंग न्यूज, ये आदमी लगातार डीएसए इंटरव्यूज क्रैक कर रहा है, जरूर कोई चीटिंग हो रही है इंटरव्यूज में।
अरे भाई चीटिंग कैसी, मैं तो सिर्फ लीको एआई के साथ प्रिपेयर करता हूँ।
And have it point.
This was so AI generated, honestly. Funny.
A new try. Insert A and have it point to a new try which says end with 0. It's not ending here, but the count prefix is 1 over here. Remember, A is pointing to a try. A is pointing to a try which will have end width as 0 and count prefix as 1 because there is a word that starts with A. Because there is a word that starts with A for sure. Perfect. Next, you'll come to this try. Yes, you'll come to this try. Now you're standing at this try. When you come to P. Now when you come to P, does it have a P? No. So please make sure you insert a P and you create a corresponding try for that. Yes, you create a corresponding try for that with end width as 0 and count prefix as 1. Just make sure. Now what you do is, you were here, now you'll come here. So now you're standing here and you're at the next P. Does it have a P? No. Please insert a P and make sure it is pointing to a new try which will have end width as 0, count prefix as 1. Perfect. Now you're standing at this try and you're at L. Does it have an L? No. Please insert an L. So you'll insert an L and this will now point to a prefix. Sorry, this will now point to a try. So you are done with L. Now you are having E. So let's have E. EP as 1 because there does exist.
Right, so modifying the array itself is a bit tricky. Yeah, so they're just using variables inside the node. But then again, you try and make methods out of it and it becomes so complicated.
a word which starts with apple, but you have inserted everyone. So can I say that's the end of the word? And if it is the end of the word, you're standing at this try, the last word, the last word, yes, you'll go over there and you'll say, hey, listen, you're the last word, right? So end with 1 and counterfeit stays as 1. So I'm saying end with will be incremented to 1, end with will be incremented to 1. That is what I'm saying to you. Absolutely makes sense. So apple has been inserted. Okay, next time. So you're done with the first insertion. Let's come to the next insertion, which is apple. Now again, you start with the root of the tree. What are you looking for? A. You are standing here. A is done. Now go to P. That means you just change the try. The word that starts with A. So just make sure you increase that. Right? Yes, we have an A. Whose A is try? This one. So there is a word that starts with A. So just make sure you increase that. Right? You are standing here. A is done. Now go to P. That means you just change the try. You go to the next one. Perfect. You're standing here and you are at P. Does P exist? Yes, P exists. Whose P is try? This one. Please increase. Perfect. Now you are standing over here. Standing at here. Does L exist? Yes. Whose L try? Here. Increase the prefix. Perfect. I will be understanding why am I increasing the prefix. Because we know that there does exist a word which starts with A, AP, APP, APPL, APPLE. Correct? Next. Change this to 2. Correct? Now can I say the word is completed? And if the word is completed, where are you standing at the end? Here. And if you're standing here then, what you'll do is, you will say, there's one more that APP, you'll always get APP, and that's exist. Yes. Who's the prefix? This one. Increase. Exist. Yes. Who's the prefix? This one. So what you say, I will insert an S and I'll create a try for that. I'll insert an S and I'll create a try for that with end with. That's what you say. I will insert an S and I'll create a try for that. I'll insert an S and I'll create a try for that with end with a 0 S. So prefix is 1. Now I can say this word has been completely inserted. So it ends with S. It ends with S. SS try is this one. So make sure this die has been changed to 1. Ending with will be changed to 1. Initially we are the root. Perfect. Standing at over here. This one. On the flow. For every word's try, you increase the count prefix, and whenever you're ending at for that try, you increase the count end. That is what you will do. Perfect. So we have specifically done the insert operation. Now count words end. Like how many words are ending with? How do you count? How many words are ending with apps? Or how many words are ending with ABC? Okay, let's take these 2 examples and check this out. So we have initially apps, and I have to tell how many words are there that ends with apps. Initially you stand with root. Do you have A? You have. That's the try. Perfect. Please move to the try. Do you have P? Yes. Who's the try? Here. Please move to that. Next. You have P. Yes. Who's the try? Move. Next you have S. Who's the try? This one. Move to here. You are ending. You're done with apps. You're standing here. How many? No. If B does not exist, you'll say, hey dude, go back. There's no one that ends with this. So the answer to this will be 2. Perfect. Next. A, B, C. Does A exist? Yes. Who's the try? This one. From here, you'll go here. Does B exist? No. If B does not exist, you'll say, hey dude, go back. There's no one that ends with this. There's no one that ends with this. Perfect. Let's do the next portion. Count words start with. Yes, count words start with. So if I'm saying how many starts with AP, you're initially starting with root. Does A exist? Yes. This is the try. Okay. I move here. What's the next? Does P exist? Yes. We move here. We are almost done with this. We are done with AP. How many? For this P, what's the value? 4. So there are 4 words.
1.4 crores in interest alone. The problem is nobody teaches us this in school, and that is exactly what we want to change at the 1% Club.
What's the other thing that I'll be requiring? I'll be requiring something like delete end. And it's very simple. When you do the opposite, which is count end with minus minus, and then you require void reduce prefix. It's a similar one. I just added some other functions. This is how the struct will look like. The classes on the right and the struct almost similar. Now what we'll do is we will go across and create it. Now as usual, we always require something which is known as a root of the tree rather. So what we'll do is we will say, okay, let's create the root of the trie, which is node star root, and in the constructor let's do one thing. Whenever the constructor is called, let's create a new object for that struct. So that for every object called, there's a new. Now as usual, we always require some other functions.
Bro, this logic is so much more cleaner than what I wrote. I'll try not to modify the array next time.
This is how the struct will look like. The classes on the right and the struct almost similar. Now what we'll do is we will go across and create it. Now as usual, we always require something which is known as a root of the tree rather. So what we'll do is we will say, okay, let's create the root of the tree, which is node star root, and in the constructor let's do one thing. Whenever the constructor is called, let's create a new object for that struct. So that for every object called, there's a new trie that is given to them. Okay. Now over here we have to insert it. So if you remember properly, we always took up a node which is initially standing at the root, correct? And then we iterated on the word that is given to us. So let's iterate quickly on the word that's given to us. That's something like this. And what we will say is, okay, now what do we require? If the node does not contains this particular word I, that means it is not there, right? In that case, I'll say node, can you please put across this word I with a new node? That means a reference node will be put across. Now once you put across the reference node, can I say that, okay, you put across the reference node for a particular guy. Now can you go across to that guy, which is again very simple. You will just be saying, just go across to that try. Once you've gone to that try, can I say, you will simply say, okay, that try, can you increase the prefix? Because there's a guy with the same prefix plus plus. Can you increase the prefix? I'll be like, okay, I am perfect. So please increase the prefix. So he's increasing the prefix. Once you've done the entire stuff, whenever you're at the end, can I say, if you're at the end, can you say, can you please increase my end? I think I can. I can. So since I wrote down all these functions, it becomes much more readable. I'm saying increase prefix, increase end, put does not contains. So this is how you can write the insert. Quite simple. Count words equal to. Again, a very simple one. Again, if I just write this one on the parallel, it's kind of like you take a node initially with the node equal to root. And what you do is you go across 0, and then you are like, let's go across to the size, and then do an I++, and then what you do is if the node contains this key, which is something like this, what I, then it's perfect. Then it's absolutely perfect. Let's go to that what I. If it contains, and if it does not contains, then can you please return a 0 saying, hey, listen, there's no one with that. And if you are going like apple, A, P, P, L, E, then when you're reaching the end, you just need the get, like how many ends are there? Have we written the get end? I think we have missed the get end over here. Okay.
Yeah, so he didn't delete any memory, right? Right, so a few problems over here, right? I need to keep on restarting the capture. I'll take a look into it, why that's the case, right? Apart from that, yeah, done with 2 lectures, I guess. And now I've got a job I need to and focus on, right? And that's what I'm gonna do. That's it for right now, at least. I'm not sure about today. I'm gonna be busy today, probably, right? Okay, thanks for joining, and I'll see you guys next time, right? Bye bye. Where's the OBS? Yeah, there it is. No, wait. So yeah, it's lagging even, right? That's not okay. I've got to check into why that's happening.